So I'm Craig Scott-Angell. This is my former colleague now, David Brownhill. We worked together for a few years at Skyscanner, where we got into security testing. Prior to that, my experiences as a software tester. I now work in a small tech startup in Edinburgh. David now works for the DVSA. So we're quite passionate about security, and today we're hoping to demonstrate some of the things we've been doing and hopefully give you some names of tools and things that maybe you can go away and look at yourself, maybe integrate into some of the things you're doing. So to get started, so traditionally, security testing has been done by specific pen testers and security experts, but I think it's probably best to try and break that kind of silo and get more people doing it. In today's climate, it's a matter of when, not if you get hacked, and a lot of people in this room, you may have already been hacked and actually not be aware of it right now. You just don't know. So yeah, there's a big impact in things when they go wrong, brand tarnishing, data protection issues, etc. A lot of companies are now reactive. They have plans in place if they do have a breach. They do some pen test and they tick some boxes, but it's probably best to be proactive and as early as possible. So what we're going to talk about today is going to be a bit more of a proactive approach. So yeah, traditionally security testing is bolted on at the end. You might get third parties come in and do pen testing. You may have people, maybe a team in security that does things, but it's always better to maybe do that at the source, in the teams and in the projects you're working in. What you want to do, or what we've done in the past, is try and build a security conscious culture. That involves everyone, and you want to sort of build security into the culture, the methodology, how people are working, and actually automate as much as you can, just like you would with any other testing. So we started off when we were at Skyscanner looking at education. The biggest risk in any organization is human error. It leads to defects, security issues, even down to the person on reception, giving away information or social engineering attacks. So we felt it's important where we work now and where we've worked in the past to make sure that people are security aware to the relevant levels. One thing we did was we put into place training opportunities in Skyscanner. I'm also doing that where I'm at now, although it's a bit easier, some smaller teams where I'm at. And what we find is that if you can get a champion in each team, someone that's passionate about security, they don't have to be an expert, but somebody that will champion it in each project that you can work with, that helps you get the buy-in in each team. We did find actually, because if you watch TV at the moment, hacking is quite popular, cyber security, all this sort of stuff. Sounds cool, so people weren't actually that against learning some of this stuff. Part of that, we ran workshops, doing SQL injection workshops, looking for cross-site scripting, and we even had people that weren't necessarily testers or devs sort of interested in that get involved as well. So it actually was quite easy for us to get people looking at this. So one of the main things that most companies have started doing a lot of is static and dynamic security scanning. These are great, particularly I like static scanning from a security perspective, because that does look at the code base. It looks for security issues early on, but they can be quite timely, and they're usually paid for services, so there's a cost involved in that as well. We've used in the past various sort of companies that do a great job, but you're still looking at uploading your files externally, so that's an issue for some people. And also the feedback that comes back can take a day, 2 days, depending on the type of things you're looking at. So really you want to get things in early. So part of that is running it as part of your software development lifecycle. So we did an assessment when we first started looking at this, and there's a lot of different frameworks out there. So 3 I'm going to mention. There's BDD-Security from Continuum. Mitten was a Burp Suite integration. Burp Suite's a proxy tool. And Gauntlet, which is a Ruby-based one as well. David's going to give a real-life example of the Gauntlet. I'm going to talk through BDD-Security scenario that we implemented. There's other things out there as well, so there's a lot of paid-for services. Dynamic scanning, which sort of scans the application while it's running for web apps. There's a good tool out there we've started using called Arachne Scanner. It's a free open source tool. It's multi-platform. It's got an integrated browser environment, so it's fairly good out of the box, but it's highly configurable for scans and plugins. Yeah, so continuous delivery pipelines are quite popular in Agile environments. You get quick feedback, you get your tests running. Something I probably should mention, security scanning probably isn't as quick as some people would like, particularly if you have to scan real websites, spidering, etc. So whereas unit tests will run in sort of minutes, you are looking 20 to 30 minutes on average from our experience of scanning for full security vulnerabilities. But if you can run it regularly, you get earlier feedback. So BDD-Security uses predefined BDD scenarios. Before I start talking about this, is there anyone not familiar with Gherkin syntax, given, when, then, BDD testing? Are you all familiar? Yeah, so I don't have to go into too much detail there. Traditionally, everywhere I've worked in the last sort of 4 or 5 years is using things like Cucumber and that given, when, then to write their automated tests. So it slots in nice and easily with what people are used to, using it for security as well. We found that product was able to understand what we were testing from a security requirement point of view, and also we could get into the definition of done, which meant that security was one of the things we had to do on our development. So the strategy we took, to try and get buy-in, we assessed the teams high, medium, low for risk, the type of services they produce, code bases, what type of data they're handling, that type of thing. And we wanted to get buy-in, so what we did, we chose a high risk team with multiple API, data services, etc. And we used those as a profile to start with this and then show it to the rest of the company to get buy-in to roll out elsewhere. We assisted and supported, but ultimately we wanted to get everyone in that team involved, so they took ownership eventually of those tests running. What we did find when we first started out was that we could split the test into a set of core tests, so stuff that went across the entire website, and those can be run separately to each team's specific tests for, say, API level or whatever they're working on. But we did it all in one for this profile just to be able to roll it out. So technical details. So what is BDD-Security? So you can go online, you can have a look at it. There's a load of help files, how-tos, etc. But it's highly customizable Java framework. The main tool that it drives is OWASP Zed Attack Proxy. So that is based around the OWASP top 10 security vulnerabilities. It's also extensible with plugins, and it has an API. If you're not interested in running the rest of these things, it can be driven on its own. It does come with a Java client, a Python client, and a few unofficial ones in Ruby, etc. So, and there's an API you can drive it with. SSLyze is a tool for your SSL vulnerability, what ciphers you're using. You can set various things within that for different levels of scans and vulnerabilities, etc. Selenium, we're all familiar for front-end testing. Nessus Security Scanner is an infrastructure scanner. That's quite a good one I've used in the past as community edition as well if it's paid for. And it runs as JUnit tests. The example I'm going to run through is version 1 of the framework. We use JBehave, Apache Ant, but have released a version 2 now, which uses Cucumber and Gradle. It's simplified a lot of the setup and running of the tests. But go away, have a look at it. There's a lot of information online. So I guess I don't need to go into BDD, what it is, stories, etc., since everybody seems aware. What you can do with the tool is pass in attack strength. Depending on that is how long your scans run. The Zap scanning is probably the core of what it comes with out of the box. You can do high, medium, and low. Obviously, if you're doing the high, it's quite invasive. It can knock over your servers, so things to be aware of there. You can also pass in any false positives so they don't come through in future. It's fully configurable for restricted areas. You can have different credentials, etc. You can crawl your website via the tool, or you can use Selenium to do specific things. So one thing I found in all my training, anyway, is that a lot of stuff's focused on the non-functional security, so your infrastructure, making sure the ports that you require are only open, and other things like that. But increasingly with web applications, with mobile applications, there's a lot of security built in with things like two-factor authentication, captures, and limiting login attempts. So the Selenium built into this actually helps with all of that as well to run particularly for your web applications. You could integrate other tools for mobile as well if you wanted to do that. So you get the benefit of being able to essentially test both. You can also, one thing we did was integrate a REST client to attack our API level. What we find from a security point of view is if you can get a better security on the API level, you're a bit easier on the top level Selenium because they can be flaky. So if you make sure the API level is secure, you can be a little bit more forgiving on the top level. So yeah, it comes out of the box with lots of different stories. You can test session management, authentication, SSL, your different headers, host config. It comes with these all predefined that you can just configure for your application and the type of things you want to test within that. One thing we did was cross-origin request, resource sharing, sorry. And that was a new feature we put back into the framework. We do think if you're going to use things for free, it's always best to try and contribute where you can. I'm hoping I've got another one coming through soon that I'll release, but I won't go into detail on that, but watch this space, there might be extra features coming in. This is a typical story for open ports. You're testing, the expected ports are open. And the one we put back in, you can test that you're allowed cross-origin and you're forbidden cross-origin. So from an implementation point of view, we were using TeamCity at the time. Where I'm at the moment, we're using Circle CI, and I'm only in the middle of integrating this now. But TeamCity was fairly straightforward to integrate. We used Git for our source control. We used AWS for our environment. One thing with AWS that was great that we found was that each team, if they wanted to roll out, could just generate their own environment when they needed it, run the tests from there into our data center at the services they're targeting. And it meant there was a cost saving. We didn't have to have servers that we had to manage. We just built it when we needed it, and we ran it. So results, you have various outputs, JUnit, HTML, everything's time-stamped, and you can pull all that back into your integration server and see the results. This is an example of the old-style report. The Cucumber ones are much nicer, but you can basically click through these, get all the outputs and the failures. Pulled into TeamCity, you can get your things out of there. It's quite extensible, so we did find trying to display in TeamCity wasn't quite as nice as some of the HTML. So sometimes it was nicer for debugging to go back to the HTML reports. But for a quick glance, having a look in your integration server was the first port of call. So what do we get out of this for value? So our security requirements are easily defined. It slots right in with what we're doing with our functional testing. People are fully used to using BDD, and they understood what we were doing. It eased pushing security into, eased introducing security into teams from that. But ultimately, early testing, early feedback, you want to make sure that what comes back is treated like any other defect as soon as possible. That reduces cost. But it also meant that people were thinking about security. So when we had cards coming through, we could tag them. There's a security element to this. We need to do an extra test, just like we would with acceptance testing, functional testing at the different layers. It gave us more confidence in what we were releasing. Generally speaking, we had a build run every evening. We could release on a daily basis, but depending on the work, we didn't. So having an evening run and coming in the morning made sense. But you can obviously drive it as you want. All tests are taggable, so you can do subsets. You can do things related solely to one service and just run what you need to. But ultimately, it reduced the risk in what we were releasing. So David's going to give an example of the Gauntlet and what he's the Gauntlet framework and what he's been doing with that in the DVSA. So I'm just going to switch. Slide. David.
Okay, so I actually work for. I hope this is working. It'll be too loud.
Hold it up, David.
Yeah. I work for BJSS, and alongside KNOS, we've been developing the digital services for DVSA MOT application security. MOT is, as it says, it's an online service which all the garages within the UK will input the details of an MOT test, which they're doing against your car. So we integrate with DVLA for validating the licensing, and as the engineer, work against your brakes and your suspension and anything engine based. All this information's input into the system, and then if you're lucky, or you'll get a certificate out the other end, and it'll be stored against DVLA, and away you go. So KNOS, I think they're sponsoring this conference, and they do all the dev work. BJSS, who are based in Leeds. If you know Leeds at all, we're straight opposite this Sky Bet campus in the city centre. We look after the infrastructure, tech support. So if you're in a garage and something's gone crazy, then we're the guys you call up. And we do all the testing, both functional and non-functional. And I'm a member of the non-functional team. This is a hierarchy of the DVSA digital service. So looking from the left to right, software development, we've got feature teams. So we have releases about every fortnight with amendments and improvements coming back from the business teams. In the middle, the architecture, we've got performance guys, security guys, myself, and information assurance. So that's all sort of compliance and vulnerability assessment and potential threats and the impacts that they'll have, and from there an assessment of potential security improvements are provided, which feed into us, and we look to act on those. And then on the far right hand side is technical support surface. That's based out of Leeds, just the whole infrastructure, mostly now switched over to AWS. And the non-functional testing, so as each release comes out, we'll have the NFRs, and we'll both regression test the application, make sure it's not any slower, ensure the throughput is maintained. I mean, on average, we'll have about, coming in from the garages, about 450, 470 MOT tests per minute. Obviously, we don't want to dip below that. But at the moment, I think we're managing 750, 800 with ease. Okay, continuous delivery pipeline. So this is an ongoing implementation coming out of the architecture team. So again, looking from left to right, we've got integration testing. That's all the integration points, all the components that make up the MOT application, and making sure that, talking to the database correctly, and the front end working with the APIs. And moving on, we've got the NFT and acceptance. So the NFT, that's our guys, and as I said, we've got scripts which run end-to-end and also test specific areas of the application. Acceptance, that's functional testing. It's both Selenium, PHP, and also is obviously a level of exploratory testing as well on that environment. Once those two pass, we go through the pre-prod. Pre-prod is a mixture of both functional and non-functional. So from a non-functional point of view, we have, as Craig mentioned there's a level of security. I mean, obviously, it's a complete move of production. So, and that's got a security scanning tool called Encapsula running on it. So that does affect the performance results because it's extra load running against the environments. But I mean, even then, we're hitting sort of 680, 700. It's a dip down from NFT. So we're just running the same scripts again. as we did on NFT and in production, and it's out. Okay, so the continuous integration plan is currently on 2.1, it's going out. So we started off at the top there. You can see our front end is written in PHP. So we ensured a level of unit test coverage, and we talked about the integration environment. So we're ensuring that all the component level testing is completed. Local and feature build environments, that's local environments, what I just talked about, the NFT and pre-prod. Feature build environments, each of the feature teams will have access to AWS environments which they can spin up. We've got 20 available. There's 3 feature build teams, so you basically just put your request in on a Trello board and say, I'm taking feature build 2 for some security testing, feature build 7 for I'm going to be running some Selenium tests against that one, and I'm taking a feature build 12 for some performance tests on, I know, some sort of print certification changes I'm doing, and each of the feature build environments will have a level of performance testing as well as security testing within each of the teams before it comes to the actual non-functional team itself. UI-driven functional Selenium stuff. 2.1, backend, all our APIs written in Java. So same again, ensuring that the coverage is maintained there. And SonarQube is a static analysis tool. Currently, we don't allow it to break a build. And we also, it doesn't have a great level of security rule sets at the moment. It's mostly for correctness of style for coding. But we are looking to introduce some custom tests for security and performance on that, because obviously your coding will affect how performant the application is. And then 2.2, at the moment the performance and security don't break the build. They run as a separate Jenkins job. Jenkins is our continuous integration server. So we're going to be putting that into the job and splitting out performance and security into different environments to enable that pipeline to run from functional to performance to security and then released out to pre-prod. So that needs to be introduced. And multi-branch pipelines, that's to separate out different features. So for example, at the moment we've got 2 feature pipelines for the standard MOT app, and we're introducing 2-factor authentication. So that at the present are 2 major feature pipelines we've got on the MOT application for the garages. Jumping on. Okay, just running through this, what SonarQube offers us for security rule sets. So the teams are encouraged to code against the OWASP top 10. OWASP top 10 is just the most popular vulnerabilities. And the OWASP give guidance as to how to code against those. So signal injection, I think if it's not number 1, it's in the top 3. Passwords, error handling, and insecure direct object references, that's a top 5 one as well. And that's basically artifacts, objects within a web page which haven't been correctly authenticated, such that, for example, database access or access to files on shared folders. And so someone can come in and usually found in sort of downloads when you're downloading a PDF or something. Okay, so Scott-Angell, when we worked at Skyscanner, we use the BDD-Security framework. I mean, what that basically is a framework off which hang a number of tools. When you're doing manual security testing, a popular tool set is the Kali Linux, which I don't know, probably has hundreds of tools on there. But in an automated environment, Gauntlet was chosen by architects as the framework of choice. So the tool sets that come off there automatically are Arachne, which we mentioned as a web service scanner, SSLyze, which is for verifying HTTPS certificates, and we wanted to introduce OWASP Zap, which I think we mentioned as well, rather than Bowstreet, specifically because it's a lower end entry to it. Just the same kind of things. So you can use it as a proxy for poisoning headers. You can use it as a mapping tool for scanning through all the paths of your application. So just like you would do with given gherkin and cucumber and BDD, you define your scenario. So these come out of from the information assurance guys. So that's a classic where cookies can be intercepted if you haven't tagged them properly. So we just went through all the cookies used on the site and verify that. Okay, so feature team responsibilities from a security point of view. Mentioned that obviously feature guys are cutting code and getting features out there. They're supposed to write JMeter scripts, basic ones. We're not asking for robust JMeter scripts. JMeter is a tool that both the NFT teams and the feature build teams use. And we've got that integrated with Jenkins. So OWASP Zap can be used to implement those scenarios. It doesn't come with a framework. One of our architects wrote a custom job such that we can run Zap as part of the Gauntlet. So you've got your scenario, and just like you would do a Selenium on SpecFlow, it's like a code behind thing. So, you know, as you've sort of given, I've got this cookie, it'll then behind the scenes call Gauntlet, hook up with OWASP Zap, and then run the script you've implemented against the Zap. So we've got tech leads for the feature build teams, and they review all the code, both from a performance, security, and functional perspective. And if there's specific rule sets for the work that they've been working on a particular sprint, then we define those in the rule sets, and they'll be run on NFT. Customized attack vectors is just because we've introduced another feature, and then it's a potential attack from outside. You know, there's a free text field which potentially might be a vulnerability, and we'll add that onto our rule sets. Okay, so we've got the feature build guys and what they're doing. What's the non-functional team doing? So we're going from left to right. We've got the feature build. They've spun it up, they've done the testing. It's then been bounced across to a non-functional environment. We have regression. Obviously, we've got scripts that we run, you know, they make feature changes. We want to make sure it's still performing at the level that the throughput is supposed to be having. Now, active scans using functional automation scripts, OWASP Zap, rather than you know, writing scripts that progress through the application, we can piggyback on back of the functional Selenium scripts that have been developed, and that'll give us coverage through the application. And then when it's sort of entering, you know, data in you know, like a brake on the front left wheel or something, we can ensure via a SAP that there's no SQL injection issues with that input field, for example. So we can just make a tweak to the functional automation script there. Targeted attacks, that's the Zap files that the feature teams have written, so they'll put out to us. We can, you know, improve those or just make them more stable, and we'll review those coming out of the feature build teams. And the targeted execution, that's whereby, okay, the feature builds have given us some Zap files, but we may not reuse their script, but we'll certainly be adding to our vectors as the features increase, just as you would do with our JMeter on performance. So new features coming in, we'll expand our target execution, and then they'll feed into our regression for the following sprint in a fortnight's time. Okay, so this is just more of a summary thing. So when I was saying that the NFT taken it from the feature build, so we've got environments which we'll run our security tests against. We've got environments for our performance tests, and when the pipeline is eventually completed, so we've got an end-to-end direct release. both those environments will be part of the red-green. So generated scripts, both for the feature builder and NFT environment, attack scenarios, Gauntlet framework that we're going to be using to provide the tooling, and the ZAP active scans, coming out of the feature builds, and pinpointing particular vulnerabilities. So I think that's it.
Yeah, so really what we're trying to get across is there are tools out there you can use in continuous integration for security. There are frameworks that you can use, there are tools individually you can use. Some of the places I've worked weren't familiar with them. We've gone out and found them, but hopefully you can go away with some of these names. I think the slides are going to be shared anyway, and obviously the talk. Go away, have a look. Some of these tools you can do entire talks and workshops on. You can't fit it into one talk in 45 minutes. But yeah, go away, read about it, see if it fits with what you're looking at, and hopefully you can take something out of it and get some value from those tools.